Welcome to Sleep Science, Top 1. Tonight, we gently begin a journey far beyond our familiar world, soaring into the vast universe where humanity once dared to dream and conquer. A journey filled with wonder, triumphs, and hope for our future and the generations to come. A realm filled with marvels, accomplishments, and aspirations brought to life. The remarkable story of space travel opens before us, from those first cautious rocket launches to the bold dreams of tomorrow. Right above us, beyond the thin veil of atmosphere, lies a realm that once seemed forever out of reach, yet through intelligence, courage, and perseverance, humanity crossed that boundary. Above us, beyond the delicate layer of atmosphere, exists a domain that previously appeared unattainable, yet through ingenuity, courage, and persistence, they have crossed that threshold. They have walked on other worlds, constructed homes in orbit, and dispatched their creations to the edge of the solar system and beyond. If these peaceful journeys bring you calm, please like, subscribe, and drop a quick comment below. Your single share can guide another tired soul here. One person, one night at a time, we spread relaxation and belief in a brighter future together. Now, just relax your body, find the most comfortable spot, and let this gentle story of humanity's cosmic journey softly carry you into deep sleep. Breathe slowly, and let's begin. The initial aspirations of soaring through the skies. Long ago, before rockets pierced the sky, the dream of flight already captured human hearts. In ancient myths, heroes wore wings, rode chariots drawn by divine horses, and soared toward the sun and moon. Those stories weren't just legends, they were the burning desire to reach the impossible, a desire we pass on to our children today. These transcended mere tales. Their essence captured a longing that resided profoundly within the human soul, a yearning to ascend from the ground, to discover what awaited beyond the limits of the sky. In China, legends narrated the tale of Chang'e ascending to the moon. In Greece, Icarus soared near the sun, his tale unfolding with deeper significance. These narratives, despite their fantastical nature, contained a kernel of truth, the notion that, at some point, humanity could transcend the earth beneath their feet. For centuries, that dream appeared to be perpetually unattainable. As birds soared freely above, humans remained earthbound, their gazes filled with envy. Yet the longing never diminished. It lingered silently across the ages, biding its time for the wisdom and means that would render it achievable. The night sky held a deeper significance beyond mere admiration. It was a place, far away yet beckoning. Each star represents a potential refuge. Each planet, a realm that could someday embrace the touch of explorers. The emergence of rocketry. The tale of space travel commences not with magnificent contraptions, but with humble tubes filled with powder. In their most primitive form, rockets were conceived in China over a millennium ago. In their infancy, these rockets resembled mere fireworks, bundles of gunpowder affixed to arrows, propelled to instill fear in foes or to commemorate festivities. They ascended amidst swirling flames and billowing smoke, wild and perilous. Yet, they demonstrated a fundamental truth, that controlled explosions had the power to elevate objects into the sky. For centuries, rockets existed as mere curiosities, serving as instruments of war or spectacle, and nothing beyond that. Yet, during the late 19th and early 20th centuries, a select group of visionaries started to recognize their genuine possibilities. In Russia, a schoolteacher named Konstantin Tsiolkovsky diligently filled notebooks with calculations, envisioning rockets capable of breaking free from Earth's gravitational pull. Though he never constructed a single one, his equations established the groundwork. In America, the first liquid-fueled rocket was launched by Robert Goddard in 1926. A modest device ascended a mere few dozen meters before plummeting into a patch of cabbages. What appeared trivial in that moment was, in fact, the inception of something greater. In Germany, a young engineer named Wernher von Braun harbored aspirations of launching rockets to the moon. His work, unfortunately, found its initial application in the service of destruction during the Second World War. Yet, following the conclusion of the conflict, his insights would serve as a catalyst for the dawn of the space age. The rocket, previously seen as both a weapon and a toy, was on the brink of transforming into something much more significant, a means of discovery, connecting our world to the vast universe beyond. The era of space exploration begins. On the 4th of October 1957, a small metal sphere rose into the sky over Kazakhstan, no bigger than a beach ball, weighing less than 90 kilograms, carrying only a simple radio transmitter. Yet, Sputnik, humanity's first artificial satellite, changed history forever, opening the real era of space exploration for all of us. Nevertheless, the influence it had on history was beyond measure. This was Sputnik, the inaugural creation of humankind that ventured into the cosmos as the first artificial satellite. As it orbited the Earth every 96 minutes, its rhythmic beep resonated throughout the globe. For the first time, an object had been placed in orbit by humanity. The era of space exploration had commenced. The accomplishment reverberated across countries. In America, individuals gazed skyward, their expressions a blend of awe and apprehension, coming to the realization that if satellites were capable of circling the Earth, then weapons could do so as well. A race commenced, driven not solely by the pursuit of scientific accomplishment, but by the quest for supremacy in this uncharted territory. In the ensuing months, additional satellites emerged. Sputnik 2 embarked on a journey with a living passenger, a dog named Laika, demonstrating that life could endure in the vast emptiness of space. Although Laika did not come back, her journey represented a significant milestone achieved. Sputnik's gentle beep-beep echoed for 3 weeks before fading, but its impact never did. For the first time, humanity placed an object in Earth's orbit, launching the true age of cosmic discovery. The sky transformed into something tangible, no longer an unattainable barrier. It transformed into a thoroughfare, a realm where the constructs of humanity could move unimpeded. The aspiration to touch the stars transformed from mere fantasy into something tangible. It was unfolding, each moment bringing it closer to reality. The initial human to venture into the cosmos. Less than 4 years after Sputnik, on the 12th of April 1961, a young Soviet cosmonaut named Yuri Gagarin sat inside a capsule atop a giant rocket. He became the first human in space, a giant leap for mankind that still inspires millions of children today. At 27 years of age, he was a pilot, known for his calm demeanor and easy smile. What awaited him was an experience unlike any other known to mankind. The rocket ignited, and the ground trembled as it ascended into the sky, taking Gagarin far from all that was known to him. In a matter of moments, he stepped beyond the confines of Earth, marking the historic moment as the first human to venture into the vastness of space. Gagarin's flight spanned a mere 108 minutes, completing a solitary orbit around the Earth before his capsule made its descent back to the ground. Yet in that fleeting moment, he beheld what no one else had ever seen. The Earth's curvature, the atmosphere's delicate thinness, and the vast blackness of space, all illuminated by the dazzling brilliance of stars. He transmitted straightforward observations, painting a vivid picture of the beauty of his home world from above. His serene voice resonated through the emptiness, conveying a sense of victory and awe. When he landed safely in a field, Gagarin instantly became a hero. His feat proved humans could survive in the endless void, opening not an ending, but a brand new beginning for all of us. A door had been opened, and now others would step through it. The aspiration for space travel had transcended the realms of scientists and engineers alone. It was a collective triumph, a testament to what humanity could accomplish together. The nation enters the competition. The triumph of Yuri Gagarin ignited a sense of urgency within America. In less than a month, astronaut Alan Shepard ascended into a small Mercury capsule and embarked on a journey into space aboard a rocket. His flight was short, lasting only 15 minutes, and it did not circle the Earth. Yet, it marked the beginning. The nation had entered the space race, and the rivalry grew fiercer. President John F. Kennedy, motivated by the challenge, addressed Congress and proclaimed an ambitious objective. Before the decade concluded, a man would be sent to the moon by America and safely returned. It was a bold commitment. At that moment, American rockets had managed to send a man into space for merely 15 minutes. The means to journey to the moon had not yet been developed. The journey demanded spacecraft of immense size and complexity, navigation systems of unmatched precision, and the bravery of individuals ready to gamble it all. Yet the commitment was established, and the efforts commenced. In the span of 1,960 seconds, the actions of both America and the Soviet Union extended the limits even further. In the vastness of space, cosmonauts and astronauts dedicated extended periods to their orbits, mastering the art of living in weightlessness, skillfully maneuvering their spacecraft, and bravely stepping outside to float amidst the emptiness. With each mission, the narrative unfolded, addressing challenges, honing skills, and gradually approaching the ultimate objective. Space had transformed into a realm not merely traversed for a fleeting moment, but one that beckoned for deeper exploration and understanding. It was evolving into a domain where humans could toil, endure, and ready themselves for even grander adventures. On the 18th of March 1965, Soviet cosmonaut Alexei Leonov opened the hatch of his spacecraft and floated outside, embarking on a journey that would be remembered in history. Connected by a slender line, he made history as the first human to traverse the vastness of space. For 12 minutes, he floated in the stillness, enveloped by the endless void, while the Earth rotated gradually beneath him. It was both beautiful and terrifying. The vast emptiness extended endlessly, with only the delicate material of his suit standing between him and the void of space. Leonov's spacewalk was fraught with peril. His suit expanded in the vacuum, rendering it rigid and challenging to maneuver. As the moment approached for his return, he found himself grappling with the challenge of maneuvering through the constricted airlock. For a fleeting instant, it appeared as though he could be ensnared outside, destined to drift away. Yet he succeeded in alleviating some of the pressure from the suit, compressing it sufficiently to slip through. As the hatch sealed shut behind him, he found himself soaked in sweat, weary yet very much alive. Just months later, American astronaut Ed White embarked on his own spacewalk, gracefully floating outside Gemini for a remarkable 23 minutes. It was described as the most peaceful experience of his life, embodying a feeling of total freedom. Stepping away from the spacecraft and placing complete trust in the delicate equipment that ensured survival demanded a level of faith that was rare among individuals. Nevertheless, those initial spacewalks demonstrated that it was indeed possible. Individuals had the ability to operate beyond their crafts, fix machinery, and construct edifices. The capacity to traverse the expanse of space would prove crucial for all that was to come. The moon calls out softly. As the seconds ticked by, the aspiration of reaching the moon became increasingly tangible. The Saturn V rocket was developed by NASA, a towering giant that reached the height of a 36-story building. The engines generated an unprecedented amount of thrust, capable of trembling the Earth for miles in every direction at the moment of launch. The spacecraft designed to transport astronauts to the moon, including the Apollo Command and Lunar modules, underwent construction and rigorous testing. Each element underwent careful examination, and every process was practiced meticulously. In December 1968, Apollo 8 embarked on a journey that took 3 astronauts beyond the confines of Earth's orbit for the very first time. They did not land on the moon. Instead, they orbited it, witnessing its ancient, cratered surface from a close vantage point. As they gazed upon Earth, a delicate blue marble floating in the void, they recited from the Book of Genesis, to an audience of millions tuning in from their homes. On Christmas Eve, a fleeting sense of wonder enveloped the journey, rising above the realms of politics and rivalry. It transformed into a collective experience for everyone. The triumph of Apollo 8 demonstrated that the moon was attainable. The technology functioned as intended. The navigation was executed with precision. The astronauts were capable of enduring the journey. At this point, only the landing was left. The instant when human feet would make contact with an entirely new world for the very first time in history. That moment was just around the corner, and the world held its breath in eager anticipation. One modest stride. On the 20th of July, 1969, two men descended to the moon's surface in the fragile spacecraft called Eagle. Neil Armstrong and Buzz Aldrin stepped out the moment of one small step for man, one giant leap for mankind. As it detached from the command module, hovering above, the descent unfolded with palpable tension. As alarms blared, the computer reached its breaking point. The designated landing area lay strewn with boulders, compelling Armstrong to take control manually as he sought a secure spot to touch down. The fuel dwindled. Mission Control observed with growing anxiety as the seconds slipped by. At last, the crackle of Armstrong's voice emerged from the radio. The Eagle has arrived. After 6.5 hours, Armstrong opened the hatch and descended the ladder to the surface. The entire world observed from their screens as his boot made contact with the lunar dust. He remarked, "That's one small step for man, a monumental stride for humanity." The words, though simple, held the profound significance of every dream, every calculation, and every sacrifice that had led humanity to this pivotal moment. They were no longer confined to Earth. They had become travelers among worlds. Aldrin joined him on the surface, and together they spent 2.5 hours outside, planting a flag, collecting rocks, and photographing the stark landscape. They advanced with deliberate, bounding leaps, perfectly suited to the moon's feeble gravity. The sky above them appeared dark, even in the brightness of day, as the moon lacked an atmosphere to diffuse the light. One could observe Earth suspended in the vast darkness, a stunning blue oasis amidst the emptiness. As they ascended into the lunar module and reunited with Michael Collins in orbit, they brought along not merely moon rocks, but evidence that the unimaginable could indeed manifest into reality. The Apollo legacy continued as 5 additional Apollo missions achieved successful landings on the moon following the historic journey of Armstrong and Aldrin. They ventured through various landscapes, from the undulating hills of the Fra Mauro Highlands to the majestic peaks of the Taurus Littrow Valley. The astronauts traversed the surface in lunar rovers, nimble vehicles that etched their paths into the timeless dust. Experiments were set up, lunar soil was drilled into, and hundreds of pounds of rock samples were brought back, continuing to be the subject of scientific study even today. Apollo 13, which was launched in April 1970, ultimately did not make it to the moon. 2 days into the mission, an oxygen tank exploded, leaving the spacecraft in a state of disarray. The 3 astronauts aboard, Jim Lovell, Jack Swigert, and Fred Hayes, encountered a daunting decision. To turn around at once would mean risking the depletion of life support, while continuing the journey around the moon could harness its gravity to propel them back toward Earth. They opted for the latter, facing a relentless stretch of cold, diminishing supplies and an air of uncertainty. Their survival, a testament to the ingenuity and teamwork between the crew and mission control, emerged as one of spaceflight's most celebrated triumphs. While the landing may not have been successful, the rescue certainly was. The last Apollo mission, Apollo 17, took to the skies in December 1972. Astronauts Eugene Cernan and Harrison Schmitt, the first scientist astronaut to visit the moon, dedicated 3 days to the exploration of the Taurus Littrow Valley. As they ascended into the lunar module for the final time, Cernan lingered on the ladder, breaking the stillness with his words. "We leave as we came, and God willing, as we shall return, with peace and hope for all mankind." As they ascended, They left behind footprints that have remained untouched ever since, preserved in the stillness of the airless surroundings. Humanity had touched the moon, and although we have not returned since, that achievement continues to resonate with significance. Skylab, recognized as the inaugural space station, stands as a significant milestone in the history of space exploration. As the moon missions reached their conclusion, focus shifted towards an exciting new endeavor. Is it possible for humans to inhabit space for long durations? Not merely days, but weeks, or perhaps even months? In 1973, NASA initiated the launch of Skylab, marking the advent of America's first space station. It was vast. Constructed from the upper stage of a Saturn V rocket, it provides space for 3 astronauts to inhabit and operate in a degree of comfort. Power was supplied by solar panels, while a large telescope enabled observations of the Sun that were unattainable from the surface of the Earth. The launch of Skylab was on the brink of catastrophe. As the ascent progressed, a micrometeorite shield was ripped away, resulting in the loss of one solar panel and causing the other to become jammed. The station achieved orbit, yet it was severely damaged, suffering from overheating due to direct sunlight and constrained power supply. After 11 days, the first crew embarked on their journey, only to encounter an unexpected repair mission. They set up a temporary sunshade, unblocked the stuck solar panel, and revived Skylab. It served as an early lesson in the ingenuity necessary for enduring the challenges of extended space travel. Over the course of the next year, 3 crews made their way to Skylab, culminating in a final mission that spanned 84 days. The astronauts adjusted to the weightlessness of space, engaged in exercise routines to stave off muscle deterioration, and carried out numerous experiments. As they observed Earth from above, they captured images of weather patterns, the glow of cities at night, and the ethereal auroras swirling over the poles. As the final crew departed in February 1974, Skylab stood vacant, gradually succumbing to the pull of atmospheric drag, its descent inevitable. It made its return to the atmosphere in 1979, disintegrating over the Indian Ocean and spreading fragments across Australia. Despite its short existence, Skylab demonstrated that humanity could flourish in the cosmos, paving the path for even more daring space stations. The era of shuttles commences. On the 12th of April, 1981, precisely 2 decades after Yuri Gagarin's groundbreaking journey, a novel spacecraft ascended from Kennedy Space Center. The Space Shuttle Columbia stood apart from all that had come before it. Earlier spacecraft were designed as capsules, utilized for a single mission and then abandoned. The shuttle was crafted to ascend with the force of a rocket, yet descend with the grace of an airplane, embodying reusability and the ability to transport substantial payloads into orbit. The astronauts, John Young and Robert Crippen, took command on its inaugural journey, circling the Earth for 2 days before gracefully returning to a runway in California. The mission unfolded flawlessly, marking a significant new chapter in the realm of space exploration. The shuttle fleet ultimately expanded to encompass 5 orbiters, with Challenger, Discovery, Atlantis, and Endeavour joining Columbia. In the following 30 years, they initiated satellite launches, deployed the Hubble Space Telescope, transported astronauts to space stations, and conducted numerous experiments. The shuttle's cargo bay was spacious enough to accommodate a school bus, and its robotic arm was capable of grasping satellites for repair or releasing them into orbit. It emerged as the backbone of American space exploration, a recognizable presence as it ascended alongside twin solid rocket boosters into the heavens. Nevertheless, the shuttle was marked by sorrow. On the 28th of January, 1986, the Challenger met a tragic fate, exploding just 73 seconds after its launch. All 7 crew members lost their lives, including schoolteacher Krista McAuliffe, who was set to become the first private citizen in space. The disaster led to the grounding of the shuttle fleet for almost 3 years, as NASA undertook a thorough investigation and redesign of essential components. On the 1st of February 2003, Columbia met a tragic fate as it disintegrated during re-entry, resulting in the loss of its crew of 7. These losses served as poignant reminders of the inherent dangers of spaceflight, highlighting the fragile line that separates success from catastrophe. Yet, in the face of challenges, the shuttle program pressed on, accomplishing extraordinary feats before concluding its journey in 2011 after 135 missions. As the shuttle soared through the cosmos, the vision of a new kind of space station began to take shape. This ambitious project promised to be far grander and more expansive than Skylab, with plans meticulously crafted for a home in orbit. The International Space Station emerged as a remarkable collaboration among the United States, Russia, Europe, Japan, and Canada. The construction commenced in 1998 as modules were launched individually and assembled in orbit. Astronauts undertook numerous spacewalks, linking power cables, setting up equipment, and broadening the structure. Completion spanned over a decade. The ISS stands as a colossal structure, comparable in size to a football field, offering habitable space akin to that of a 6-bedroom house. Solar panels extend gracefully, harnessing energy from the sun's rays. Within the confines of their shared environment, astronauts hailing from various corners of the globe coexist and collaborate, engaging in experiments that span the realms of biology, physics, and materials science. Researchers explore the ways in which the human body adjusts to weightlessness, the growth patterns of plants in microgravity, and the unique behavior of flames in the absence of gravity. The station orbits Earth every 90 minutes, moving at a speed exceeding 17,000 miles per hour, positioned so that the planet's curvature is perpetually in view. Residing on the ISS necessitates adjustment. In the realm of weightlessness, the concepts of up and down dissolve, allowing astronauts to glide effortlessly through the modules, utilizing handholds to navigate their surroundings. In small cabins, sleep occurs within sleeping bags secured to the wall, preventing any drifting away. Consuming food demands a mindful approach. Crumbs and liquids drift away, leading to the packaging of most food in pouches. Water holds immense value and is repurposed, encompassing the moisture released through breath and sweat. Even urine undergoes processing and purification, an essential task when resupply missions are separated by months. In the face of numerous challenges, astronauts frequently recount their experiences aboard the ISS as deeply fulfilling, an opportunity to dwell among the stars and play a part in advancing knowledge that serves the greater good of humanity. The Mir space station. Prior to the ISS, there existed Mir, a space station of Soviet origin that later became Russian, orbiting Earth from 1986 until 2001. Mir stood as the inaugural modular station, constructed gradually as fresh segments were launched and incorporated. At its height, it comprised 7 modules, offering areas for research, living accommodations, and docking ports for incoming spacecraft. Cosmonauts resided on Mir for extended periods, with one, Valery Polyakov, achieving the remarkable feat of 437 consecutive days in space, a record that endures. Life on Mir presented numerous challenges. Equipment often malfunctioned, and the need for repairs was a persistent reality. In 1997, a fire erupted, engulfing the station in smoke and compelling the crew to put on oxygen masks. Later that same year, a resupply ship met with an unfortunate fate as it collided with the station during docking, resulting in a punctured module and subsequent depressurization. The crew succeeded in sealing it off, just in the nick of time. Yet, in the face of these challenges, Mir persevered, and the insights gained became essential for the development of future space stations. In the late 1990s, American astronauts embarked on journeys to Mir, engaging in a collaboration with Russia. The missions cultivated a spirit of collaboration and established trust among former adversaries of the Cold War. As Mir met its fate in 2001, It descended from the heavens, igniting in a fiery spectacle over the Pacific Ocean, with fragments cascading down into the tranquil waters below. Having surpassed its expected duration by several years, it stood as a symbol of human resolve to maintain its operation. The legacy of Mir endures within the ISS, which adopted many of its design principles and upholds the spirit of international collaboration in the realm of space exploration. While humans ventured into near-Earth space, robotic explorers journeyed much farther through the cosmos. The tireless explorers have ventured to every planet in the solar system, with many extending their journeys even further. In 1976, Viking 1 and Viking 2 made their historic landing on Mars, marking the first time that spacecraft successfully functioned on the surface of another planet. The Martian soil was tested for signs of life. The rust-colored landscape was photographed, and the thin, frigid atmosphere was measured. While definitive evidence of life remained elusive, the door was opened for future exploration. In 1977, Voyager 1 and Voyager 2 were launched, seizing the opportunity presented by a rare alignment of the outer planets. The journey of Voyager 2 took it to the majestic realms of Jupiter, Saturn, Uranus, and Neptune, where it captured breathtaking images of these far-off giants and their accompanying moons. Voyager 1 embarked on a unique journey, navigating near Saturn before venturing into the vastness of interstellar space. In 2012, it achieved the remarkable feat of being the first human-made object to venture beyond the solar system, entering the realm where the sun's influence diminishes and the vast expanse between stars unfolds. Each Voyager is equipped with golden records, discs adorned with sounds and images from Earth, intended as messages for any intelligent beings that may discover them in the future. The Cassini spacecraft spent 13 years in orbit around Saturn, meticulously examining its rings, moons, and atmosphere with remarkable precision. Geysers of water were discovered erupting from the moon Enceladus, suggesting the presence of a subsurface ocean that might support life. In 2017, with fuel running low, Cassini was intentionally plunged into Saturn to prevent any contamination of its potentially habitable moons. The robotic missions extend humanity's reach far beyond where physical travel is possible, returning knowledge and wonder from the most distant corners of the solar system. The rovers on Mars. Mars has long fascinated humanity, its reddish hue evoking images of fire and the tantalizing prospect of life beyond our own world. In recent decades, a fleet of robotic explorers has been dispatched to traverse its surface. In 1997, the Pathfinder mission introduced a small rover known as Sojourner, which dedicated 3 months to examining rocks and demonstrating the capability of rovers to traverse the Martian landscape. Then arrived Spirit and Opportunity, the twin rovers that touched down in 2004. Created with a lifespan of 90 days, they surpassed all expectations. For 6 years, Spirit carried out its mission, while Opportunity astonishingly persevered for 14 years, traversing 28 miles across the remnants of ancient lake beds and the edges of craters. In 2012, the Curiosity rover, a car-sized robot equipped with 17 cameras and a suite of scientific instruments, landed in Gale Crater. Its mission was to determine whether Mars ever had conditions suitable for life. It has penetrated the depths of rocks, scrutinized their makeup, and uncovered organic molecules, the essential components of life. In 2021, the Perseverance rover made its descent to Jezero Crater, joining Curiosity at a location thought to have once been home to a lake. Perseverance transports a small helicopter known as Ingenuity, which has completed numerous flights, demonstrating that powered flight can indeed occur in the thin atmosphere of Mars. These rovers transcend their mechanical nature, evolving into companions for the scientists who operate them, imbued with personality and revered. As Opportunity's mission reached its conclusion amidst a global dust storm in 2018, the final transmission it delivered could be encapsulated in the poignant words, "My battery is low, and it's getting dark." The world grieved, These rovers serve as our eyes and hands on another world, diligently exploring, testing, and relaying postcards from the frontier. With every new revelation, we inch nearer to unraveling the mystery that lingers in every glance cast toward Mars. Had there ever been a time when solitude was absent from our existence? The quest to uncover existence beyond our planet. Among the most profound inquiries propelling the quest for knowledge beyond our planet is the question of whether life exists in other realms of the universe. Their search has manifested in various ways. Robotic missions explore the soil of Mars and examine the plumes of water erupting from icy moons. Telescopes embark on a quest to uncover planets that dance around far-off stars, seeking out realms with atmospheres that could harbor oxygen, methane, or other gases linked to the existence of life. Signals are listened for by radio telescopes, signs of advanced civilizations attempting to reach out across the cosmos. Up to this point, there has been no conclusive evidence of life existing outside our planet. Yet, the cosmos is immense, and our exploration has only just commenced. The discovery of extremophiles on Earth, organisms thriving in boiling springs, frozen tundra, and deep ocean vents, has enriched our comprehension of the potential habitats for life beyond our planet. Should life be able to thrive in such extreme conditions here, it raises the possibility that it might also endure in the subsurface oceans of Europa, the methane lakes of Titan, or the ancient riverbeds of Mars. The inquiry transcends mere science, delving into the realm of philosophy. The revelation of even the tiniest microbial life on a distant planet would profoundly reshape our comprehension of existence. This suggests that life may not be an exclusive occurrence on Earth, but rather a widespread phenomenon, potentially interlaced within the very essence of the universe. Should a simple life be prevalent, the likelihood of intelligent life civilizations akin to ours or strikingly different grows more credible. At present, the quest persists, fueled by an insatiable curiosity and the belief that eventually an answer will be revealed among the stars. The universe, as seen through Hubble's eye. Launched in 1990, the Hubble Space Telescope transformed humanity's understanding of the universe. Situated beyond the confines of Earth's atmosphere, it seizes images with an unparalleled clarity that ground-based views cannot achieve. The Hubble Space Telescope has captured images of far-off galaxies, radiant nebulae, and the tumultuous storms that rage on Jupiter. The rate of the universe's expansion has been measured, the age of the cosmos identified at nearly 14 billion years, and the discovery made that this expansion is accelerating, propelled by a mysterious force known as dark energy. Among Hubble's most remarkable accomplishments are the deep field images. In a remarkable feat, Hubble directed its gaze towards an unassuming stretch of sky, gathering light over several days. This effort unveiled thousands of galaxies within an area no bigger than a grain of sand held at arm's length. Every galaxy is home to billions of stars, with many so far away that their light has journeyed for billions of years to arrive at our eyes. These images evoke a sense of the universe's immense scale, a boundless expanse teeming with more galaxies than one can fathom, each holding the possibility of worlds and perhaps even life. Hubble has observed the birth and death of stars, capturing images of stellar nurseries where new suns ignite and supernova remnants where old stars explode, revealing a profound narrative of cosmic transformation. It has followed comets, examined black holes, and even identified the atmospheres of planets circling distant stars. After more than 3 decades in orbit, Hubble remains operational, its discoveries transforming our comprehension of the universe. It transcends the mere function of a telescope. It serves as a time machine, revealing the cosmos as it existed billions of years ago and reminding us of the vast mysteries yet to be uncovered. In December 2021, the James Webb Space Telescope made its grand entrance into the cosmos. Destined for a point in space nearly 1 million miles from Earth, Webb stands as a larger and more powerful counterpart to Hubble, featuring a mirror that spans over 20 feet, and instruments finely attuned to infrared light. This enables a glimpse beyond the obscuring dust clouds that hinder visible light, uncovering concealed stars and galaxies from the universe's earliest times. The initial images from Webb, unveiled in 2022, were nothing short of stunning. It revealed the most profound perspective of the universe ever attained, showcasing galaxies that emerged merely a few 100 million years following the Big Bang. It unveiled the environments of exoplanets, identifying water vapor and carbon dioxide on planets circling far-off stars. It captured the pillars of creation, a star-forming region once imaged by Hubble, in breathtaking new detail, revealing infant stars concealed within the dust. Webb's mission encompasses the exploration of the universe's origins, the formation of galaxies, the life cycles of stars, and the characteristics of planets that exist beyond our solar system. It embodies the forefront of technological advancement, a partnership among NASA, the European Space Agency, and the Canadian Space Agency. Every image it transmits serves as a portal to the universe, uncovering formations and occurrences that push the boundaries of our comprehension. As it continues its work, Webb is set to unveil answers to long-standing questions, while also introducing a host of fresh inquiries, expanding the limits of our understanding. The allure of distant worlds beyond our own. Throughout the vast expanse of human history, there existed a profound curiosity about the possibility of planets revolving around distant stars. In 1995, the question found its answer as astronomers identified the first exoplanet circling a sun-like star. Since that time, countless others have come to light, with fresh announcements made on a regular basis. They arrive in a remarkable array. Massive gas giants, surpassing Jupiter in size, revolve around their stars at distances even closer than Mercury. Rocky super-Earths, boasting masses several times greater than our own, and planets that revolve around binary star systems, their skies illuminated by the light of two suns. Some of these worlds are located in the habitable zone, the area surrounding a star where conditions permit liquid water to be present on a planet's surface. Water holds a vital role in sustaining life as we understand it, making these planets especially intriguing. Instruments such as the Kepler Space Telescope and the Transiting Exoplanet Survey satellite have uncovered thousands of potential candidates. Observations conducted with telescopes such as Webb are starting to reveal details about their atmospheres as they seek out chemical signatures that could suggest the presence of life. The variety of exoplanets indicates that planetary systems are prevalent, and in the presence of planets, the possibility of life emerges. It remains uncertain whether any of these worlds are home to life, yet the quest to uncover the truth is intensifying. Each new discovery enhances our comprehension of the factors that contribute to a planet's habitability and draws us nearer to resolving the question of our solitude in the universe. In the vast expanse of the universe, countless worlds exist, each distinct and each holding the promise of life within its embrace. Private spaceflight begins to take shape. For decades, space exploration belonged to governments, supported by taxpayers and fueled by national pride. However, as the 21st century unfolded, private companies started to make their presence felt in the arena. SpaceX, established by the visionary Elon Musk, created the Falcon 9 rocket, which was crafted with a focus on partial reusability. Rather than being discarded after launch, the first stage descends gracefully, poised for another flight. This breakthrough has significantly lowered the expenses associated with achieving orbit. In 2020, SpaceX's Crew Dragon capsule embarked on a historic journey, transporting astronauts to the International Space Station, marking the first occasion a private company successfully launched humans into orbit. Other companies are adopting similar practices. Blue Origin, established by Jeff Bezos, has created rockets designed for suborbital tourism, providing short journeys to the brink of space, allowing passengers to enjoy a few moments of weightlessness. Virgin Galactic operates a spaceplane that ascends to comparable heights. These ventures are opening up the cosmos to a broader audience, allowing not only professional astronauts, but also private citizens eager to invest in the experience. Private spaceflight is opening doors to innovative types of missions. Companies are envisioning the mining of asteroids for resources, the construction of commercial space stations, and the establishment of infrastructure to support future exploration of the Moon and Mars. The transition from government-led to commercial spaceflight is expanding the space frontier in ways that seemed inconceivable just a few decades prior. The aspiration for space has transcended the boundaries of nations. It is becoming an industry, a new arena for innovation and enterprise. As humanity prepares to return to the Moon, it marks a significant moment more than 50 years after the last Apollo mission. The Artemis program, initiated by NASA, seeks to achieve the remarkable goal of landing astronauts on the Moon's surface by the mid-2020s, marking a historic moment with the inclusion of the first woman and the first person of color in this monumental journey. In contrast to Apollo, which emphasized exploration and scientific discovery, Artemis is crafted with a vision for enduring sustainability. The goal is to establish a permanent presence, building infrastructure that will support extended stays and serve as a stepping stone for missions to Mars. At the heart of Artemis lies the Lunar Gateway, a compact space station destined to orbit the Moon. It will serve as a staging point for lunar landings, a research laboratory, and a platform for deep space exploration. The Gateway will come together piece by piece, with contributions from various nations adding to its construction. It represents a new model of international cooperation, building on the lessons of the ISS. On the lunar surface, astronauts will explore the South Polar region, an area of particular interest because it contains ice deposits in permanently shadowed craters. This ice could provide water, oxygen, and even fuel, resources essential for sustaining a lunar base. Returning to the Moon is not just about repeating past achievements. It is about building a foundation for the future, creating the technologies and experience needed to venture even farther into the solar system. The vision of Mars. Mars has long been the ultimate destination for human space exploration. It is the most Earth-like planet in the solar system, with a day length similar to ours, polar ice caps, and evidence of ancient rivers and lakes. Though its surface is now cold and dry, with a thin atmosphere mostly carbon dioxide, Mars may have once been warmer and wetter, a place where life could have emerged. Plans to send humans to Mars are ambitious and complex. The journey would take 6 to 9 months, and astronauts would need to spend at least a year on the surface, waiting for Earth and Mars to align favorably for the return trip. This means a mission would last 2 to 3 years, far longer than any human has spent away from Earth. The challenges are immense. Radiation exposure during the journey, the psychological strain of isolation, the need to produce food, water, and oxygen on Mars. Yet the vision persists. NASA, SpaceX, and other organizations are developing the technologies required. Rockets powerful enough to carry the necessary equipment. Habitats that can withstand the Martian environment. Life support systems that can recycle resources with near-perfect efficiency. The first Mars missions will likely establish small outposts, gradually expanding as more supplies and people arrive. The dream is not just to visit Mars, but to stay, to build a second home for humanity and ensure our survival as a species. Living on other worlds, establishing permanent settlements on the Moon or Mars, will require reimagining how humans live. Everything we take for granted on Earth, breathable air, drinkable water, protection from radiation, must be engineered. Habitats will likely be built using local materials, Martian regolith, or lunar soil, possibly shaped by 3D printers into structures that provide shelter. Growing food in space is another challenge. On the ISS, astronauts have successfully grown lettuce, radishes, and peppers. But scaling this up to feed an entire colony requires solving problems of soil, lighting, and pollination. Hydroponics and aeroponics, methods that grow plants without soil, may offer solutions. Producing enough food to be self-sufficient will take time, and early settlers will depend on shipments from Earth. Psychologically, living on another world will be demanding. Settlers will be far from home, with communication delays of several minutes to Mars and no possibility of rapid rescue if something goes wrong. They will live in confined spaces, surrounded by a hostile environment. Yet humans have always adapted to new frontiers, from deserts to polar ice. The settlers of the Moon and Mars will be pioneers, building the foundations of civilizations that may one day thrive independently of Earth. The power of nuclear propulsion, one of the greatest obstacles to exploring the outer solar system and beyond, is the time it takes to get there. Chemical rockets, the kind used for all human spaceflights so far, are limited by the energy they can produce. A journey to Mars takes months, and reaching the outer planets would take years or decades. To shorten these trips, new forms of propulsion are being developed. Nuclear propulsion is one promising option. Nuclear thermal rockets heat a propellant using a nuclear reactor, producing exhaust that accelerates the spacecraft. This method is far more efficient than chemical rockets, potentially cutting the travel time to Mars in half. Nuclear electric propulsion, which uses electricity from a reactor to accelerate ions, offers even greater efficiency for long missions to the outer planets. These technologies are not just theoretical. NASA and other space agencies are actively developing them. Tests have been conducted, reactors designed, and missions planned. Nuclear propulsion could revolutionize space travel, making the outer planets accessible within a single human lifetime and opening the possibility of journeys to nearby stars. The challenge lies not in the physics, which is well understood, but in the engineering and safety considerations. Building reactors that can operate reliably in the harsh environment of space requires meticulous design and testing. Yet the potential rewards, faster travel times, access to distant worlds, make it a goal worth pursuing. Solar sails and light propulsion. Another elegant method of propulsion relies not on fuel, but on light itself. Solar sails are vast, ultra-thin sheets of reflective material that catch photons from the sunday. Though individual photons carry minuscule momentum, the cumulative effect of billions striking the sail can accelerate a spacecraft. The acceleration is gentle, but continuous, and over time, a solar sail can reach impressive speeds without consuming any fuel. The concept was once pure science fiction, but it has become reality. In 2010, Japan's Ikeros spacecraft deployed a solar sail and successfully used it to navigate through space. More ambitious projects are in development, including missions to intercept interstellar objects passing through our solar system. Some visionaries propose using powerful lasers to propel tiny spacecraft to nearby stars, accelerating them to a significant fraction of light speed. Solar sails represent a fundamentally different approach to space travel, one that harnesses the natural resources of the cosmos. Sunlight is abundant and free, and a sail requires no complex machinery, just material and patience. For missions that do not require speed, where the journey can unfold over years or decades, solar sails offer a graceful and efficient way to traverse the void. The dream of interstellar travel. The stars beyond our solar system are unimaginably distant. The nearest, Proxima Centauri, is over 4 light-years away. With current technology, reaching it would take tens of thousands of years. Yet humanity dreams of making that journey, of stepping onto worlds orbiting alien suns. Interstellar travel remains firmly in the realm of theory, but theories are where all great journeys begin. Several concepts have been proposed. Generation ships, massive vessels that would house entire communities, traveling for centuries, while multiple generations live and die aboard. Suspended animation, placing travelers in a state of hibernation to survive the long voyage. Antimatter propulsion, harnessing the most energetic reactions known to physics. Each concept faces enormous challenges, but none violate the laws of physics. They are difficult, not impossible. The Breakthrough Starshot initiative proposes a different approach, sending tiny, lightweight probes, accelerated by ground-based lasers, to a fraction of light speed. These probes have the potential to arrive at Proxima Centauri in 20 years, transmitting images and data from a distant star system. Though it would not transport humans, it marked humanity's inaugural, concrete stride toward the cosmos. Evidence suggests that interstellar travel can be realized. At this moment, the stars linger as far-off glimmers in the dark expanse above. Yet every remarkable journey starts with a single step, and humanity has repeatedly demonstrated that what appears unattainable can transform into the ordinary. The species that once perceived the sky as an unyielding boundary now finds itself dwelling among the stars in orbit. The aspiration for interstellar travel might require centuries to come to fruition, yet it remains a vision deserving of our hope, a narrative that motivates and pushes us to strive for greater heights. The dawn of space tourism unfolds. In 2001, American businessman Dennis Tito made a remarkable investment of $20 million to experience 8 days aboard the International Space Station, marking his place as the first space tourist. The journey he embarked upon signified the dawn of a transformative age, an age in which the cosmos was accessible not solely to seasoned astronauts, but to all who possessed the means and the yearning to explore. Since that time, a select few have embarked on similar journeys, investing in voyages to orbit, feeling the sensation of weightlessness, and looking down at the Earth from a breathtaking vantage point. In recent years, the realm of space tourism has witnessed significant growth. Companies such as SpaceX, Blue Origin, and Virgin Galactic provide flights that ascend to the edge of space, granting passengers a brief experience of weightlessness and breathtaking views of Earth's curvature. These suborbital flights may be short, yet they offer passengers a glimpse into the experiences of astronauts. The expense remains significant, reaching hundreds of thousands of dollars. However, it is gradually decreasing as advancements in technology and rising competition take effect. The overarching vision is increasingly bold. Orbital hotels, lunar resorts, and journeys around the moon unfold in a narrative that reveals fresh significance. Although these developments are still years in the making, the groundwork is being laid. Development is underway for private space stations, crafted with a focus on both tourism and research. As access to space becomes increasingly commonplace, the experience will open up to a wider audience. Space tourism transcends mere adventure. The narrative revolves around shifting our viewpoint, perceiving Earth as a delicate sanctuary amidst the immense expanse of space, a perspective that astronauts articulate as deeply life-altering. The overview effect unfolds. Astronauts who have ventured into space frequently recount a profound emotional experience, known as the overview effect. From orbit, Earth reveals itself as a delicate, diminutive sphere, adrift in the vast void of space. The fragile blue line of the atmosphere stands out, serving as the sole shield between existence and the emptiness beyond. The boundaries that separate nations remain unseen. The planet appears as one, a cohesive and interconnected whole. This viewpoint transforms the way astronauts perceive humanity. Conflicts that seem significant from the ground take on a different perspective when viewed from above, revealing their triviality. The understanding that everyone inhabits a single planet, with no alternative, becomes deeply felt. Numerous astronauts come back with a revitalized dedication to safeguarding the environment, fostering peace, and promoting collaboration. There is a profound sense of connection to all life on Earth, an acknowledgement of a collective destiny that binds us together. The overview effect extends beyond the realm of astronauts. As an increasing number of individuals venture into space for tourism, a profound transformation in perspective will unfold for many. Images and footage captured from space have already provided a glimpse of it to countless individuals. The iconic Earthrise image from Apollo 8, depicting Earth ascending above the Moon's horizon, played a significant role in inspiring the environmental movement. As we observe our planet from the vastness of space, a deeper appreciation for its beauty and fragility may emerge, inspiring us to take action in its preservation. The asteroids that circle the Sun in the region between Mars and Jupiter hold immense treasures waiting to be discovered. Metals such as iron, nickel, and platinum are found in concentrations significantly greater than those on Earth. Water ice, found within certain asteroids, holds the potential to be converted into hydrogen and oxygen, serving as a source of rocket fuel. Extracting these resources has the potential to supply the essential materials for constructing spacecraft, habitats, and infrastructure in space, thereby lessening the reliance on launching all supplies from Earth. Numerous companies have emerged with the ambition of mining asteroids. The technical challenges present considerable obstacles. Recognizing appropriate objectives, connecting with them, gathering resources in a microgravity environment, and bringing them back. However, the possible benefits are vast. A solitary massive asteroid may hold more platinum than humanity has ever extracted from the Earth. The economic value is astonishing, possibly trillions of dollars. Beyond the realm of economics, the potential of asteroid mining opens up avenues for more profound exploration of space. Fuel, derived from asteroid water, has the potential to be stored at various depots scattered across the solar system, establishing a comprehensive network of refueling stations. Spacecraft might venture further by not needing to transport all their fuel from Earth, thus rendering missions to the outer planets more achievable. Asteroid mining remains in its early stages, yet it signifies a future in which space transcends mere exploration, evolving into a wellspring of valuable resources, a location where the realms of industry and exploration meet harmoniously. The challenge posed by space debris. Years of exploration beyond our planet have created a lasting imprint in the vastness of space. Fragments, inactive satellites, used rocket stages, pieces from crashes and detonations, all circle the Earth at high speeds. Countless fragments exist, from minuscule specks of paint to whole defunct satellites. Even the tiniest fragments pose a significant threat. At orbital velocities, a fragment the size of a marble possesses the potential to puncture a spacecraft or obliterate a satellite. The issue is escalating. With every collision, additional debris is generated, heightening the chances of subsequent collisions, a phenomenon referred to as Kessler syndrome. If left unaddressed, it might make specific orbits unviable, confining humanity to the planet. Monitoring debris is crucial, as space agencies keep a watchful eye on thousands of objects to foresee and prevent potential collisions. The ISS has skillfully navigated on several occasions to avoid potential collisions with debris. Solutions are currently in development. Ideas encompass nets, harpoons, and lasers designed to capture or deflect debris, and spacecraft crafted to safely bring down large pieces from orbit. Some satellites are now designed to deorbit themselves once their missions conclude. Engulfed in the fiery embrace of the atmosphere, maintaining the cleanliness of space is a collective duty that calls for collaboration among nations. Careful management of the orbital environment is essential for future generations to explore and utilize space effectively. Lunar bases. The aspiration to create a lasting presence on the Moon has intrigued visionaries for many years. In contrast to brief Apollo missions, a lunar base would be a permanent establishment, functioning as a research facility, a testing ground for technologies essential for Mars exploration, and possibly a center for mining and manufacturing activities. The Moon's south pole, characterized by its ice deposits and regions of nearly perpetual sunlight, emerges as the prime contender for establishing such a base. Residing on the Moon brings forth distinct obstacles. The lunar day endures for a span of 2 weeks, succeeded by a fortnight of darkness. The temperatures fluctuate dramatically, soaring to scorching levels in the daytime and plummeting to frigid lows after sunset. Without an atmosphere, it becomes crucial to safeguard against radiation and micrometeorites. Habitats must possess strength, potentially concealed beneath lunar soil for enhanced protection. However, the Moon presents its own set of benefits. The planet's gravity, which is 1/6 that of Earth's, facilitates the launch of spacecraft with greater ease. Elements such as water, ice, and regolith hold the potential to generate fuel, oxygen, and construction materials. A lunar base has the potential to host telescopes on the far side, protected from Earth's radio interference, offering extraordinary perspectives of the universe. The Moon lies just 3 days ahead, a distance that allows for swift resupply and evacuation if the situation demands it. It serves as an ideal setting for mastering the art of off-world living. The Martian colony stands as the pinnacle of challenges for human settlement. Establishing a colony in that location would necessitate some mounting challenges far greater than those faced on the Moon. The fragile atmosphere offers a degree of protection, yet it falls short of providing breathable air or adequate shielding from radiation. The chill is intense, with typical temperatures hovering around -60 degrees Celsius. Dust storms have the potential to envelop the entire planet for extended periods. Nevertheless, Mars possesses valuable resources. Water ice can be found hidden beneath the surface and at the polar regions. The atmosphere, albeit thin, holds carbon dioxide, which can be transformed into oxygen and methane. With the right treatment, Martian soil could potentially sustain agriculture. The duration of the day, only marginally extended compared to that of Earth, aligns well with the natural rhythms of human biology. These elements position Mars as the leading contender for establishing a self-sustaining human presence beyond Earth. In the early days of Martian colonies, small groups of around a dozen individuals would inhabit pressurized habitats, engaging in research and experimenting with new technologies. As time passed, the community would grow, extracting resources, producing goods, and cultivating food. The aim was to achieve self-sufficiency, thereby diminishing reliance on Earth. In time, a Martian colony might evolve into a genuine settlement, a realm where children come into the world and are nurtured, where a fresh branch of human civilization begins to flourish. The vision is bold, yet it remains attainable if we dedicate the necessary resources and determination to realize it. The process of transforming Mars into a more Earth-like environment. Some envision a future for Mars that is even more ambitious, transforming it into a world reminiscent of Earth, a process known as terraforming. The concept involves heating the planet, enriching its atmosphere, and ultimately enabling liquid water to flow across the surface, establishing an environment where humans could venture outside without the need for spacesuits. Among the suggested approaches are the release of greenhouse gases to capture heat, the placement of mirrors in orbit to direct sunlight onto the surface, or the potential impact of comets to bring water to the planet. These processes would unfold over centuries or even millennia, demanding persistent effort through generations. The possibility remains shrouded in uncertainty. Mars does not possess a robust magnetic field, which leaves its thickened atmosphere vulnerable to being eroded by solar wind. The act of terraforming provokes deep inquiries. Should an entire planet be altered, potentially leading to the destruction of any native life that might exist to accommodate our needs? Is it morally justifiable to bind future generations to such an undertaking? Could it be that humanity is destined to extend its reach across the solar system, turning desolate planets into flourishing havens? These are discussions that lack straightforward solutions. At present, terraforming exists as a concept shrouded in speculation, a vision that stretches the limits of our imagination and redefines our role as caretakers of other worlds. The tale of Voyager unfolds with a depth that enriches its significance. In 1977, 2 spacecraft embarked on a journey from Earth, destined to uncover the mysteries of the outer planets. The achievements of Voyager 1 and Voyager 2 surpassed all anticipations, delivering the inaugural detailed images of Jupiter, Saturn, Uranus, and Neptune. Active volcanoes on Jupiter's moon Io Intricate rings surrounding Saturn and geysers on Neptune's moon Triton were unveiled. Their insights reshaped the way we perceive the outer solar system. Following the conclusion of their planetary journeys, the Voyagers pressed onward into the vastness beyond. In 2012, Voyager 1 crossed the heliopause, the boundary where the sun's influence fades, and ventured into the vastness of interstellar space. In 2018, Voyager 2 embarked on its journey. They have become the farthest human-made creations, billions of miles from home, continuing to send back faint signals to Earth. Their power is destined to fade, anticipated around the year 2030, leading them into silence. Yet, they will persist in their journey through the galaxy for billions of years to come. Every Voyager is equipped with a golden record, a phonograph disc that holds the sounds and images of Earth. Melodies, salutations in countless tongues, the calls of whales, the joyous laughter of children. It serves as a communication to the universe, an affirmation of our existence and our desire to connect. The likelihood of anyone discovering these records is exceedingly slim, yet that is not the essence of the matter. The Voyagers stand as a testament to human curiosity, embodying the relentless drive to explore and comprehend the universe. It serves as a reminder that even the tiniest actions can lead us to places we never thought possible. In 2006, NASA set forth the New Horizons mission, sending a spacecraft on its journey toward Pluto. For 9 years, it journeyed through the solar system, traversing over 3 billion miles. In July 2015, it soared past Pluto, unveiling the first intricate images of the far-off dwarf planet. The images unveiled a realm that was intricately woven and more stunning than anyone had ever imagined. The surface of Pluto revealed mountains of water ice, plains of frozen nitrogen, and a heart-shaped region that captivated the public's imagination. Following its encounter with Pluto, New Horizons ventured further into the Kuiper Belt, an expanse beyond Neptune, teeming with icy remnants from the solar system's inception. On the 1st of January 2019, it passed by Arrokoth, a small snowman-shaped object. It marked the most distant flyby ever undertaken, an astonishing journey of over 4 billion miles from Earth. The images revealed a pristine, ancient world, remaining untouched since the birth of the solar system. New Horizons revealed that even the farthest corners of the solar system are accessible to us. It inspired a generation with visions of realms once perceived merely as indistinct specks, and it presses forward, relaying information as it ventures deeper into the uncharted. Each mission, such as New Horizons, broadens the horizons of exploration, serving as a reminder that there is always further to uncover. The tale of the Parker Solar Probe unfolds with a sense of wonder and discovery. As certain missions explore the far reaches of the solar system, others embark on a path that leads to its very core. The Parker Solar Probe, which was launched in 2018, is crafted to explore the Sun at an unprecedented proximity, surpassing any previous spacecraft's approach. It will ultimately come within 4 million miles of the Sun's surface, facing temperatures exceeding 2,000 degrees Fahrenheit. A heat shield safeguards its instruments, enabling the collection of data on the Sun's corona, the outer atmosphere that intriguingly possesses a higher temperature than the surface itself. Parker embarks on a quest to unravel enduring enigmas surrounding the Sunday. What makes the corona so hot? What mechanisms are involved in the acceleration of the solar wind? What are the forces behind solar flares and coronal mass ejections? The phenomena impact Earth, causing disruptions to satellites, power grids, and communication systems. Gaining insight into them may enable us to foresee space weather and safeguard our technology. The probe embarks on a journey marked by a series of flybys, skillfully utilizing Venus's gravity to inch ever closer to the Sunday. With each pass, more data is collected, gradually constructing a detailed portrait of our star. Parker embodies the pinnacle of engineering, crafting a spacecraft capable of enduring in realms untouched by human creation. It serves as a reminder that exploration encompasses not only far-off realms, but also the comprehension of the dynamics that influence our very existence. Interaction through the emptiness. As spacecraft venture further from Earth, the challenges of communication grow more complex. Radio signals, moving at the speed of light, require minutes to arrive at Mars and hours to reach the more distant outer planets. The signal from Voyager 1, sent from the depths of interstellar space, takes more than 22 hours to arrive back on Earth. Commands dispatched to far-off spacecraft demand a measure of patience. Once a signal reaches its destination, the spacecraft could have shifted position, or the circumstances might have altered. The Deep Space Network, a vast array of enormous radio antennas positioned globally, ensures communication with far-flung missions. These antennas possess the remarkable ability to pick up the faintest signals from a spacecraft located billions of miles away. Signals so faint, they possess even less strength than a snowflake touching the Earth. Upholding this connection demands careful attention and commitment, yet it is crucial. In the absence of communication, spacecraft would drift aimlessly, their remarkable discoveries fading into obscurity. Future missions might depend on laser communication, capable of transmitting larger volumes of data across longer distances. Tests are currently in progress, and the technology holds the potential to transform our connection with explorers journeying to the far reaches of the solar system and beyond. The connection we share with our robotic ambassadors weaves a tapestry of communication, allowing their explorations to enhance the experience of all humankind. The function of artificial intelligence. The realm of modern space exploration finds itself increasingly intertwined with the capabilities of artificial intelligence. The rovers on Mars are unable to be controlled in real time. The communication delay renders it unfeasible. Rather, they are designed to operate independently, recognizing barriers, determining routes, and even deciding which stones to examine. Their ability to make independent decisions is enhanced by AI, leading to a maximization of the scientific achievements they can reach. The spacecraft navigates through the cosmos, employing artificial intelligence to deftly adjust its trajectory in response to unforeseen circumstances. Future missions to distant moons and asteroids will increasingly rely on autonomy. Human operators find themselves at a disadvantage, unable to respond swiftly when separated from their craft by light minutes or light hours of delay. Trust in AI is essential for managing emergencies, performing observations, and achieving mission success. This holds a certain poetic quality. The creations of humanity, now endowed with intelligence, embark on journeys through the cosmos in our stead. They serve as extensions of our curiosity, allowing our eyes and minds to venture into realms that remain just beyond our grasp. As AI evolves, these machines could emerge as genuine allies in exploration, uncovering insights and making choices that broaden the horizons of understanding. The exploration of space transcends borders, embodying a global endeavor. The pursuit of space exploration has consistently embodied a global essence, even amidst the rivalries that fuel it. The International Space Station stands as a prominent emblem of collaboration, showcasing astronauts from numerous nations coexisting and collaborating in their endeavors. However, the scope of collaboration reaches well beyond the ISS. Collaborative efforts frequently see various countries providing resources, knowledge, or financial support. Information gathered from space missions is made available to all, enhancing the collective knowledge of the scientific community worldwide. This collaboration is practical. The endeavor of space exploration is marked by its high costs and intricate challenges, revealing that no single nation possesses the capacity to undertake it all independently. Yet, it carries an idealistic essence, embodying a vision of humanity coming together in the quest for knowledge. As astronauts from various nations join forces in the vastness of space, they reveal that unity can rise above political divides. When nations come together to explore Mars or study the Sun, they demonstrate that shared aspirations can transcend their differences. The future of space exploration hinges on the ongoing collaboration among nations and organizations. Explorations of Mars, the establishment of lunar bases, and journeys to the distant planets will necessitate collaborative efforts across nations. Treaties and agreements must consider the sharing of resources, the governance of space, and the measures necessary to avert conflict in this uncharted territory. Space presents an opportunity for humanity to create an improved framework of collaboration, rooted in collective curiosity and reciprocal advantage. The history of space exploration has often overlooked the contributions of women, yet they have been present from the very start. In 1963, Soviet cosmonaut Valentina Tereshkova made history as the first woman to journey into space, completing 48 orbits around Earth. Nearly 2 decades would pass before another woman would take that step. In 1983, the remarkable Sally Ride made history as the first American woman to venture into space, soaring aboard the Space Shuttle Challenger. Since that time, women have taken on more and more significant roles. They have taken command of space shuttles, performed spacewalks, and resided aboard the ISS for prolonged durations. Astronauts such as Peggy Whitson and Christina Koch have achieved remarkable milestones, including records for time spent in space and conducting all-female spacewalks. Women have played a vital role, serving as engineers, scientists, and mission controllers, their expertise crucial to the success of each mission. The Artemis program, initiated by NASA, seeks to achieve the historic landing of the first woman on the Moon. This endeavor stands not only as a significant milestone, but also as a testament to the advancements made in society. The future of space exploration promises to embrace the diverse talents of all humanity, creating a collective journey into the cosmos. As the journey progresses beyond Earth, the richness of diversity will emerge as a vital asset, offering varied viewpoints and abilities to tackle the forthcoming challenges. The stars are a shared treasure, and the paths we traverse to touch them ought to embody the depth of human experience. In the journey of exploring other worlds, one must reflect on the consequences of their presence in those realms. Planetary protection involves the careful measures taken to avoid contamination, ensuring that Earth microbes do not reach other worlds, and that extraterrestrial materials are not brought back to Earth. This narrative extends beyond the mere preservation of extraterrestrial landscapes. The focus lies in guaranteeing that should we discover indications of life, we can be confident they are genuinely extraterrestrial and not mere travelers from our own planet. Before launch, spacecraft destined for Mars or other potentially habitable worlds undergo a thorough sterilization process. Meticulous attention to clean environments, precise heat treatment, and thoughtful assembly significantly reduce the chances of contamination. Missions that bring back samples from distant worlds, such as those intended for Mars, will place the material in quarantine, examining it in secure facilities to confirm it presents no danger. These precautions signify an increasing consciousness of ethical considerations. Other worlds, even those that seem barren, possess a significance that transcends their practical use to humanity. These entities serve as natural laboratories, chronicling the history of the solar system and possibly harboring life. In the journey of exploration, a delicate balance must be struck between curiosity and responsibility, safeguarding the very essence of what we aim to comprehend, the faint azure speck. In 1990, as Voyager 1 ventured beyond Neptune, it directed its camera back toward Earth for one final glimpse. From nearly 4 billion miles away, it captured an image depicting Earth as a minuscule speck, a pale blue dot floating in a shaft of scattered sunlight. Astronomer Carl Sagan, contemplating this image, expressed thoughts that have echoed through time. He spoke of how that dot encompassed everyone we have ever known, every human who has lived, loved, suffered, and died. Throughout the ages, every victory and sorrow unfolded upon that tiny speck of dust. The image evokes a sense of our insignificance, highlighting the fragility and value of Earth. It encourages a sense of humility, highlighting that our disputes seem trivial when seen through the lens of the vast universe. The pale blue dot transcends the realm of mere photography. It serves as a reminder to hold dear the beauty of our world and the connections we share with one another. It serves as a reminder that, at this moment, Earth remains our sole sanctuary, and it is our responsibility to nurture it. Yet it also motivates us to extend our grasp, to venture forth, to guarantee that existence, in all its splendor and intricacy, transcends to other realms. The image serves as both a foundation and a beckoning, reminding us of our current position, while also presenting a glimpse of potential futures. The price of discovery. Exploring the vastness of space comes with a hefty price tag. The expenses of missions reach into the billions of dollars, and the costs and benefits may not always be apparent right away or easily measurable. Critics contend that these funds might be more effectively utilized to tackle issues facing our planet: challenges, hardships, environmental shifts. It is a reasonable inquiry. Why strive endlessly for distant dreams when there are pressing needs right before us? The response is found in the enduring significance of discovery. The advancements in space technology have led to the development of satellite communication, GPS, weather forecasting, and numerous innovations that enhance everyday life. The challenges of space inspire the development of innovative materials, novel methods, and fresh perspectives. The knowledge acquired about our planet, our solar system, and the universe enhances the comprehension of existence itself. Yet, beneath the surface, there lies a profound essence. The essence of humanity lies in our innate desire to explore. Throughout history, it has propelled humanity to traverse vast oceans, scale towering mountains, and explore the uncharted territories of the world. It motivates us, tests our limits, and brings us together. The aspiration to explore distant realms instills a sense of hope, painting a picture of a future where humanity flourishes beyond the confines of Earth. That vision, that hope, possesses a significance that transcends mere monetary value. In the realm of microgravity, one of the most peculiar features of spaceflight is the sensation of weightlessness. In orbit, astronauts drift effortlessly through the vastness of space. It is not due to the absence of gravity. Earth's gravitational pull remains significant at the altitude of the ISS. Rather, it is because they are in a state of continuous freefall, traveling sideways at such a speed that they perpetually evade the planet's surface. This condition of microgravity influences all facets of existence. What once seemed straightforward now unfolds into a web of complexity. Consuming food necessitates that it be either sticky or contained in packaging to avoid drifting away. Consumption occurs via straws from sealed pouches. Slumber can be quite bewildering. Astronauts, devoid of any sense of up or down, secure themselves into sleeping bags that are fastened to the walls. Engaging in exercise is crucial for safeguarding against the deterioration of muscle and bone strength. Astronauts dedicate countless hours daily to treadmills and resistance machines, secured in place by bungee cords. In surprising ways, the human body adapts to microgravity. As fluids migrate upward, they create a swollen appearance in the face, leading to a sensation of congestion for astronauts. The spine stretches, granting individuals a fleeting sense of increased height. In the absence of gravity's relentless force, bones begin to lose their density, while muscles gradually weaken and shrink. While these changes can often be undone, extended missions will necessitate measures to ensure the well-being of astronauts. Grasping the concept of microgravity holds significant importance for upcoming expeditions to Mars and further into the cosmos. The psychological challenge of isolation in space transcends mere physical obstacles, delving deep into the realm of the mind. Astronauts embarking on extended missions encounter a profound sense of isolation as they find themselves confined to limited spaces alongside the same select individuals for months on end. They find themselves distant from family and friends, facing communication delays that render real-time conversation unfeasible during their missions to Mars. The surroundings are unforgiving, leaving no chance for swift salvation should disaster strike. Researchers examine the ways in which astronauts manage their experiences, seeking to identify characteristics that contribute to resilience in such environments. Effective interpersonal skills hold significant importance. In a small, isolated crew, conflicts can rapidly intensify. Thus, hobbies and rituals emerge as sources of structure and comfort. Astronauts aboard the ISS engage in various activities, such as watching movies, reading, playing musical instruments, and maintaining connections with their loved ones through video calls. These subtle elements of everyday life contribute to the preservation of mental well-being. Future missions will have to confront these challenges with foresight and intention. Teams will be chosen not only for their technical abilities, but also for their psychological harmony. Virtual reality offers mental escapes, enabling astronauts to immerse themselves in simulations of Earth environments. Comprehending and bolstering mental health will hold equal significance to any engineering endeavor, guaranteeing that individuals who embark on space journeys can flourish rather than merely endure. The future of space stations. The International Space Station has enjoyed continuous occupancy since November 2000, yet its existence is not eternal. The modules are showing signs of age. It is anticipated that it will be deorbited at some point during the 2030s. What follows next? A variety of possibilities are currently being developed. NASA has formed partnerships with private companies to create commercial space stations. These will be smaller than the ISS, yet more modern, crafted for the purposes of research, manufacturing, and tourism. China is constructing its own station, Tiangong, with modules being launched and assembled in orbit. Other nations are exploring the possibility of developing their own platforms. In the future, one might envision a multitude of stations orbiting the Earth, each fulfilling distinct roles. Beyond the confines of Earth's orbit lies the Lunar Gateway, a station gracefully circling the Moon. Further afield, ideas emerge for stations positioned at Lagrange points, which are gravitationally stable sites where spacecraft can linger with minimal fuel consumption. These may act as crucial markers for journeys further into the solar system. The age of a solitary space station is transitioning into a web of orbital outposts, each enhancing our presence and abilities in the cosmos. Mining the Moon reveals a wealth of resources that could sustain lunar bases and facilitate missions further into the cosmos. In the depths of permanently shadowed craters, water ice awaits, holding the potential to be transformed into hydrogen and oxygen. This transformation offers a vital resource for fueling rockets and sustaining life for astronauts venturing into the unknown. Rare elements, such as helium-3, which have been deposited by the solar wind over billions of years, hold the potential to power future fusion reactors. Mining the Moon stands as a serious proposal, transcending the realm of science fiction. Various companies and space agencies are engaged in the development of technologies aimed at extracting and processing resources from the Moon. Machines would handle the strenuous tasks, boring into the Earth and moving resources to the processing centers. The Moon's low gravity facilitates the launching of resources back into orbit, presenting a significant advantage over Earth and thereby supporting the construction of spacecraft and habitats in the vastness of space. This perspective invites contemplation. Who possesses the resources of the Moon? International treaties assert that no nation may assert sovereignty over celestial bodies. However, they provide less clarity regarding the extraction of resources. As lunar mining becomes feasible, it will be essential to address the legal and ethical questions that arise. The Moon stands poised to transform into a center of economic vitality, a realm where humanity discovers the art of living and laboring beyond Earth, laying the groundwork for a civilization that reaches for the stars. Fusion propulsion. Nuclear fusion stands out as one of the most promising technologies for deep space exploration. In contrast to fission, which involves the splitting of atoms, fusion is the process of combining them, mirroring the very mechanism that fuels the sunday. Fusion generates vast amounts of energy while emitting significantly lower levels of radiation. When harnessed for propulsion, it could allow for journeys to the outer planets in mere weeks instead of years. making missions to nearby stars a possibility within human lifetimes. Fusion propulsion operates by heating plasma to millions of degrees, utilizing magnetic fields to guide it as exhaust. The technical challenges present themselves as formidable obstacles. Achieving fusion in controlled, sustained reactions has consistently presented challenges, even here on Earth. Yet, advancements are occurring. Experimental reactors have reached fleeting instances of fusion, bringing the technology closer to becoming practical. Should fusion propulsion come to fruition, it stands to revolutionize the realm of space exploration. Tasks that once spanned decades could now be accomplished in a much shorter time frame. The outer solar system, once distant and challenging to access, would now be within reach. Even journeys beyond, to the Oort cloud, or neighboring star systems, would transition from mere theory to the realm of possibility. Fusion signifies a monumental advancement in propulsion, a breakthrough that has the potential to open the doors to the galaxy. The quest for techno-signatures. As some embark on a quest for microbial life, others set their sights on uncovering evidence of advanced civilizations. These are referred to as techno-signatures, indicators of technology produced by intelligent entities, including radio signals, megastructures that modify a star's illumination, and atmospheric pollution that could solely originate from industrial activity. Discovering any of these would demonstrate that we are not solitary and that intelligence exists beyond our planet. Initiatives such as SETI, the search for extraterrestrial intelligence, meticulously examine the heavens for radio signals that could potentially be communications or unintended emissions from advanced alien technology. Up to this point, no definitive findings have emerged, yet the quest persists. As more powerful telescopes and broader surveys emerge, the opportunities for discovery increase. Each new exoplanet discovered is another potential source, another system where a civilization might exist. The revelation of a technosignature stands to be among the most significant milestones in the annals of human history. This would imply that life exists beyond our planet and has developed both intelligence and technology over time. It would provoke contemplation regarding humanity's position in the universe, pondering our relative age in comparison to others and the possibilities that lie ahead. Even if we never make contact, knowing we are not alone would change everything. The ethics of contact. If we ever encounter extraterrestrial intelligence, how should we respond? This question has been debated by scientists, philosophers, and ethicists. Some argue we should announce our presence loudly, broadcasting messages to the stars. Others urge caution, warning that advertising our existence could be dangerous. We do not know what is out there, whether potential neighbors are peaceful or hostile. There is also the question of cultural contamination. If we contact a less advanced civilization, would our presence disrupt their development? And what if we are the less advanced? Contact with a civilization thousands or millions of years ahead of us could be overwhelming, rendering our own technology and knowledge obsolete overnight. For now, these debates are theoretical. We have sent a few messages into space, like the Arecibo message transmitted in 1974, but we have received no response. Our own signals, radio, and television broadcasts leaking into space have spread only about 100 light-years, a tiny bubble in the vastness of the galaxy. If anyone is out there, they may not have noticed us yet, but the questions remain, waiting for the day when contact, if it happens, transforms them from speculation to reality. The long journey ahead, space exploration, is still in its infancy. We have taken the first steps, ventured beyond our atmosphere, walked on the moon, sent robots to distant worlds. But the cosmos is vast, and we have barely scratched its surface. The nearest star is 4 light-years away. The Milky Way stretches 100,000 light-years across, and beyond our galaxy lie billions more, each containing billions of stars. The journey ahead will take generations. Technologies we can barely imagine will be needed. Collaboration across nations, across cultures, across time. The challenges are immense, but so are the rewards. Every new world we reach expands our understanding, our possibilities. Every discovery, whether a new moon, a distant galaxy, or the first signs of life beyond Earth, adds to the grand tapestry of knowledge. Space exploration is not just about reaching destinations. It is about the journey itself, the questions we ask, the problems we solve, the ways we grow. It is about ensuring that humanity's story does not end on a single world, but continues, spreading across the stars, carrying with it the curiosity, creativity, and hope that define us. The sounds of space. Space is often described as silent, a vacuum where sound cannot travel. This is true in the traditional sense. Without air or other medium to carry vibrations, there are no sounds as we know them. Astronauts in spacewalks report complete silence, broken only by their own breathing and the voices of colleagues transmitted through radio. Yet space is not without its music. Planets and stars emit electromagnetic radiation across many frequencies. Scientists have converted these emissions into audio, creating eerie soundscapes. Jupiter's magnetosphere produces whistles and pops. Saturn's rings create a gentle hiss as particles collide. Pulses send out regular beeps, like cosmic lighthouses. Even black holes have been given voice, their gravitational waves translated into deep, resonant tones. These sounds are not merely curiosities. They carry information about the objects that produce them. By listening to space, translated through instruments and computers, scientists can study phenomena invisible to telescopes. The symphony of the cosmos plays constantly, a concert of radio waves, X-rays, and magnetic fields. We cannot hear it directly, but through technology, we have learned to appreciate its strange beauty. Training to be an astronaut, becoming an astronaut, requires years of rigorous preparation. Candidates must have advanced degrees in science or engineering, often with military or test pilot experience. The selection process is intensely competitive. NASA receives thousands of applications for each astronaut class and selects only a handful. Those chosen undergo training that pushes them to their physical and mental limits. Physical fitness is essential. Astronauts train underwater in giant pools, wearing spacesuits to simulate the weightlessness of spacewalks. They practice tasks repeatedly, learning to work efficiently in bulky gloves while floating. They experience high Guy forces in centrifuges, preparing for the intense acceleration of launch. They fly in aircraft that create brief periods of weightlessness, parabolic arcs that earn the plane its nickname, the Vomit Comet. But technical skills are only part of preparation. Astronauts learn Russian to communicate with cosmonauts aboard the ISS. They study spacecraft systems in exhaustive detail, memorizing procedures for normal operations and emergencies. They train in remote locations, Iceland, caves, deserts, learning to work as a team in harsh, isolated environments. By the time they fly, they have spent years preparing for every conceivable situation. The training is grueling, but it ensures they are ready for the challenges of space, the experience of launch. The moment of launch is unlike anything else. Astronauts lie strapped into their seats, feeling the rocket rumble to life beneath them. The countdown echoes in their helmets, then ignition, and the world begins to shake. The force builds rapidly as the rocket accelerates, pushing astronauts back into their seats with mounting pressure. Within minutes, they are experiencing 3 times Earth's gravity. Their bodies heavy, breathing difficult. The ride is violent. Vibrations rattle every bone. The roar of engines fills the cabin despite insulation. Then, abruptly, the solid rocket boosters separate, falling away. The acceleration smooths, but continues. The astronauts watch through windows as the sky outside transitions from blue to black, the atmosphere thinning. The main engines burn, pushing them faster, higher. 8.5 minutes after liftoff, the engines cut off. Suddenly, everything is silent and still. Objects that were pressed down by acceleration begin to float. Pencils, checklists, anything not secured, drifts upward. The astronauts feel weightlessness for the first time, a sensation both strange and exhilarating. They have left Earth behind. They are in orbit, traveling at 17,000 miles per hour, yet feeling as though they are perfectly still. The journey has begun. Spacewalks, stepping outside a spacecraft into the vacuum, is one of the most dangerous and awe-inspiring experiences an astronaut can have. Spacewalks, formerly called extravehicular activities or EVAs, require meticulous preparation. Astronauts spend hours breathing pure oxygen before the walk, purging nitrogen from their blood to prevent decompression sickness. They don their spacesuits, complex garments that provide oxygen, temperature control, and protection from radiation and micrometeoroids. Once outside, they are tethered to the spacecraft by cables, a lifeline that provides both safety and communication. The work is physically demanding. Even simple tasks require significant effort in the bulky suit. Astronauts replace equipment, install experiments, and repair systems, often working for 6 or 7 hours. The view is stunning, Earth filling half the sky, the sun blazing without atmosphere to soften it, stars visible even in daylight. But spacewalks are risky. A punctured suit could be fatal, tools can slip away, lost forever. Water once leaked into an astronaut's helmet, filling it and nearly drowning him before he could get back inside. Despite these dangers, spacewalks are essential. They allow repairs and upgrades that keep spacecraft functioning, and for those who perform them, the experience is unforgettable. A chance to float in the void, with only a thin layer of fabric between them and infinity, the view from orbit. One of the most frequently mentioned experiences by astronauts is the sheer beauty of Earth from space. The planet is vibrant, a swirl of blues, greens, and whites. Oceans shimmer in sunlight. Continents show their varied landscapes, deserts in gold and brown, forests in deep green, mountain ranges casting shadows, clouds form intricate patterns, spirals of hurricanes, wisps of cirrus, towering thunderstorms flashing with lightning. At night, cities glow like constellations, webs of light marking where humanity lives. Fishing fleets off the coast of Asia dot the ocean with their lamps. Wildfires appear as orange smudges. Auroras shimmer over the poles, curtains of green and red dancing in the thin upper atmosphere. And always, the thin blue line of the atmosphere is visible, a delicate shell that holds all life we know. Astronauts describe feeling a profound connection to Earth. From orbit, borders are invisible, conflicts seem small, and the fragility of our world is apparent. This perspective stays with them. Many return as advocates for environmental protection and international cooperation. The view from orbit is more than beautiful. It is transformative, a reminder of what we share and what we stand to lose. Eating in space, food in space, has evolved significantly since the early days. Early astronauts ate from tubes, squeezing purees and pastes into their mouths. It was nutritious, but hardly appetizing. Today, meals are far better. Astronauts aboard the ISS enjoy a variety of foods, some freeze-dried and rehydrated, others thermostabilized in pouches, ready to eat after heating. Menus include everything from scrambled eggs to shrimp cocktail, from beef stew to apple pie. Fresh fruit and vegetables arrive with resupply missions, a welcome treat that doesn't last long. Astronauts can add condiments. Salt and pepper come in liquid form to prevent particles from floating away, and clogging equipment. Eating is a social activity. Crews gather around a table, held in place by foot restraints, sharing meals and conversation. Taste is affected by microgravity. Fluids shift toward the head, causing congestion that dulls flavor. A preference for spicier foods is common among many astronauts as a means of compensation. In the face of adversity, mealtime emerges as a beacon of normalcy. a pause from the daily grind, an opportunity for respite. Food serves as a source of psychological comfort, a gentle nudge towards the familiar. Certain astronauts carry along their beloved snacks, delicate morsels of Earth to enjoy, as it drifted high above the world below. Sleeping in orbit, the experience of slumber in space can be quite disorienting initially. In the absence of gravity, the concepts of up and down cease to exist. There was no awareness of lying in bed. The astronauts find rest in their compact crew quarters, merely phone booths with sleeping bags affixed to the walls. They secure themselves to prevent drifting away. Some have their arms secured tightly. Others allowed them to rise into the air, awakening to discover them suspended just before their eyes. The International Space Station completes an orbit around Earth in just 90 minutes. This implies that the Sun experiences a cycle of rising and setting 16 times within a single day. Astronauts adhere to Earth time to keep a consistent schedule, as the lights were dimmed for the night. Yet, the unending cycle can render sleep elusive. Shades drape over windows, effectively shielding the interior from the sun's rays. Earplugs and eye masks provide assistance. Despite this, numerous astronauts share that their sleep in space is shorter compared to their time on Earth. In the vastness of space, it is said that dreams take on a vivid quality. Some astronauts find themselves in dreams where they are plummeting through the vastness of space, awakening in a state of bewilderment. Before they realize, they are already in the midst of their descent, constantly traversing the globe. Some envision soaring through the skies, an experience that reflects the essence of floating without gravity. Rest is crucial for well-being. Researchers explore ways to enhance it, creating improved schedules, enhancing lighting, and upgrading sleeping quarters. Rest holds equal significance in the vastness of space as it does on our home planet, Earth. Perhaps even more so, considering the challenges of life in orbit. Coming back to Earth. Returning home is anything but a soft journey. As the astronauts prepare for their return, they step into their capsule and securely close the hatch behind them. With a burst of energy, the retro rockets ignited, decelerating the spacecraft sufficiently for it to exit its orbit. As it descends into the atmosphere, the friction generates intense heat, raising the temperature of the heat shield to thousands of degrees. The capsule radiates a light reminiscent of a meteor streaking across the sky. Plasma flowed gracefully past the windows. Radio communications were rendered ineffective due to the presence of ionized gases. The slowing down is profound. Astronauts encounter gravitational forces that can reach 4 times that of Earth, firmly anchored in their seats after enduring months of weightlessness. The intensity of the heat, the cacophony of noise, and the relentless shaking create an overwhelming experience. Then the parachutes are deployed. With a swift motion, the capsule was jerked upright, its descent gradually slowing. It floats gently, swaying under the sheltering branches above, until it makes its way into the ocean or lands with a thud on the shore. Swiftly, recovery teams mobilize to provide assistance. As the hatch opened, assistance was offered to the astronauts as they emerged into the vastness beyond. Adapting to the pull of gravity presents its challenges. After months in space, the astronauts found their muscles and bones had weakened. Standing evokes an unusual sensation, weighty. Initially, some require assistance to take their first steps. The characters undergo medical checks and embark on their rehabilitation journey, engaging in physical activity to restore vitality. The change unfolds over several weeks. Yet, over time, they learn to adjust. The experience of space lingers in their memories, a recollection of drifting without restraint, of witnessing the planet from a higher perspective, of existing amidst the celestial bodies. Space medicine. Maintaining the well-being of astronauts in space necessitates the use of specialized medicine. The effects of microgravity on the body unfold in surprising manners. Bones experience a decline in density at a pace of 1 to 2% each month. Muscles weaken, even with daily exercise. In certain astronauts, fluid shifts lead to vision problems. Pressure accumulated behind the eyes. The risk of cancer rises with exposure to radiation, particularly during missions that venture beyond the safeguarding embrace of Earth's magnetic field. Medical professionals keep a vigilant eye on astronauts. Samples of blood and saliva are collected on a regular basis. Ultrasounds examine alterations in the heart and blood vessels. Astronauts adhere to rigorous exercise routines, devoting 2 hours each day to treadmills and resistance machines. To combat the decline of muscle and bone strength, nutrition is meticulously overseen to guarantee sufficient levels of calcium, vitamin D, and various other essential nutrients. Addressing illness or injury in the vastness of space presents significant challenges. The ISS is equipped with a compact medical kit. However, significant challenges necessitate a return to Earth, an endeavor that unfolds over hours, fraught with its own inherent risks. Future missions to Mars will present challenges for swift returns. Thus, spacecraft will require enhanced medical capabilities, perhaps even medical centers. Telemedicine provides assistance, as doctors on Earth guide astronauts through procedures via video link. The realm of space medicine is expanding rapidly, crucial for facilitating extended missions and the ultimate establishment of human presence beyond our planet. The price of floating in zero gravity. Existing in a state of microgravity exacts a significant price. Beyond the deterioration of bone and muscle, astronauts encounter various health challenges. The immune system diminishes in strength, increasing the likelihood of infections. In the passage of time, wounds tend to mend at a languid pace. The cardiovascular system adjusts to the diminished demands placed upon it. The heart diminishes ever so slightly, and the blood pressure decreases. The alterations are primarily capable of being undone. Yet, they build up gradually as time passes. Changes in vision raise significant concerns. Almost 2/3 of astronauts encounter a decline in vision during extended missions. The pressure within the skull rises, applying pressure to the optic nerve while compressing the eyeball. Some astronauts require more powerful eyewear. Throughout their mission and upon their return, researchers are examining various countermeasures, from exercise devices that generate artificial gravity using centrifugal force, to dietary supplements that may help lower fluid pressure. Radiation presents a significant danger. The magnetic field of Earth provides a protective barrier against a significant portion of the sun's radiation and cosmic rays. However, in the vastness of space, astronauts are exposed to significantly greater levels. This elevates the risk of cancer, particularly for endeavors that extend beyond the confines of low Earth orbit. Protection proves beneficial. However, it brings significance, and no practical measure can completely shield against all radiation. Future spacecraft might feature specialized shelters, regions equipped with additional shielding, providing a safe haven for crews during solar storms. Grasping and addressing these risks is crucial for missions that extend over long durations. The cultivation of food in outer space. For brief missions, transporting food from Earth proves to be a sensible choice. However, for extended travels to Mars or the establishment of lasting colonies, growing food in space emerges as a necessity. The ISS has functioned as a platform for experimenting with space agriculture. Astronauts have successfully cultivated lettuce, radishes, peppers, and even flowers. Discovering the effective methods in a microgravity environment. In the absence of gravity, plants exhibit unique growth patterns. Roots do not inherently grow downward. Thus, unique systems lead their way. The water remains stagnant. Hydroponic methods, which involve cultivating plants in nutrient-rich water, prove to be more effective than traditional soil-based growing. Lighting requires meticulous management. LED arrays deliver the precise wavelengths essential for plants' photosynthesis. Ensuring proper air circulation is essential to avoid the accumulation of carbon dioxide around leaves. The harvests, though modest, hold great importance. Fresh food elevates spirits and offers nourishment that packaged meals simply cannot rival. It also embodies independence, a significant move towards autonomy from Earth. Future missions will require more expansive growing areas, perhaps entire modules focused on agriculture. Essential crops such as potatoes, wheat, and soybeans must be grown. Cultivating food in space transcends mere nourishment. It revolves around the creation of sustainable habitats, locations where humanity can genuinely thrive rather than merely exist. The robotic companions, alongside the astronauts on the ISS, find themselves in the company of others. Their space is shared with robots. Among the external elements is Canadarm2, a robotic arm exceeding 50 feet in length, designed to grasp visiting spacecraft and maneuver equipment during spacewalks. Some individuals engage in their tasks indoors. Simon, a floating sphere adorned with a screen that showcases a simple face, employs AI to aid astronauts, responding to inquiries and offering guidance. These robots serve as invaluable assistants. These entities undertake tasks that are either perilous or monotonous for human beings. They require neither rest, nor food, nor air. Some are created to examine the exterior of the station, looking for any signs of damage. Some engage in experiments, executing procedures with meticulous attention to detail. With the progression of AI, these robots evolve into increasingly proficient entities, gaining insights from past experiences and choosing paths independently. The dynamic between astronauts and robots is transforming. In the beginning, machines served as instruments that required direct human operation. Contemporary robots resemble colleagues, demonstrating the ability to act independently. Future missions could depend significantly on the use of robots. In the initial stages of colonization, robots had the capability to construct habitats, extract resources, and ready locations prior to the arrival of humans. They broaden our horizons, enabling us to achieve greater things together than we ever could on our own. In the expansive solitude of the cosmos, they might even find solace in each other's company. The peril of radiation. Outside the safeguarding embrace of Earth's magnetic field, the vast expanse of space is permeated by radiation. The sun releases a steady flow of charged particles. The solar wind flows through the cosmos, a silent yet powerful force shaping the celestial landscape. At times, it unleashes more powerful surges during solar flares and coronal mass ejections. Next, one must consider the presence of galactic cosmic rays. High-energy particles emanate from supernovae and other tumultuous occurrences throughout the galaxy. These particles possess the ability to infiltrate the hulls of spacecraft and the bodies of humans. The effects can vary significantly, from being minor to quite severe. Prolonged exposure to low doses heightens the risk of developing cancer. Increased exposure leads to acute radiation sickness, accompanied by symptoms such as nausea, fatigue, and damage to the immune system. The most energetic particles possess the ability to disrupt the functioning of electronic equipment. Safeguarding astronauts presents a significant challenge. While water and hydrogen-rich materials serve as effective shielding, their weight poses a challenge. Some designs suggest encasing crew quarters in water tanks that also serve as radiation shields. Strategically scheduling missions to steer clear of solar storms proves beneficial. Forecasts of space weather monitor the sun's activity, providing warnings about perilous eruptions. On Mars or the Moon, astronauts might find refuge in shelters concealed beneath the soil, offering remarkable protection. Grasping the complexities of radiation and crafting effective countermeasures stands as a vital endeavor for humanity's journey beyond the confines of low Earth orbit. In the absence of solutions, extended missions pose significant and unacceptable dangers. However, by taking the right precautions, it is possible to manage those risks effectively. The mechanics of orbital rendezvous, docking to spacecraft in orbit, unfolds as a delicate dance. It demands exacting calculations and expert navigation. As a capsule embarks on its journey to meet the ISS, it does not soar straight toward the station. Instead, it moves into an orbit beneath the station, slowly closing the distance. As it nears, thrusters ignite to fine-tune speed and course, drawing it nearer. The concluding approach unfolds with a deliberate and cautious pace. The two spacecraft are required to align their velocities with precision, gliding in flawless harmony as they approach one another. The process is guided by cameras and sensors, revealing alignment and distance. Upon making contact, the docking mechanisms activate, drawing the spacecraft closer and forming a secure, airtight seal. The hatches swung open, allowing the crews to traverse between the vehicles. The principles of orbital mechanics often defy common sense. Accelerating to intercept another spacecraft may unexpectedly elevate you into a higher, more leisurely orbit, resulting in a loss of ground. Slowing down brings you into a different, swifter path. Pilots are required to navigate in 3 dimensions, considering the orbital trajectories that arc around the planet. The early rendezvous missions unfolded with a palpable tension as astronauts navigated these principles through a process of trial and error. In today's world, while computers provide assistance, the importance of the human touch endures. Docking has become a customary procedure, yet it remains a remarkable feat of accuracy. Threats posed by micrometeoroids, space is filled with possibilities. Small particles, remnants of asteroids and comets, race through the solar system at incredible speeds, reaching tens of thousands of miles per hour. These micrometeoroids, often no larger than grains of sand, possess immense energy as they travel at orbital speeds. A collision has the potential to breach the hulls of spacecraft, inflict harm on solar panels, or cause windows to shatter. The ISS experiences impacts on a regular basis. Minor impacts mar the surface, creating small craters. The majority inflict no damage. The station's shielding is crafted to endure them. However, larger particles raise significant concerns. Chips marred the windows, necessitating the installation of shutters for their protection. As astronauts venture into the vastness of space, they encounter the ever-present danger of being struck, despite the multiple layers of protection their suits provide. Detecting micrometeoroids presents a significant challenge. They are elusive, emerging unexpectedly. Spacecraft are crafted with careful consideration, incorporating redundancy, multiple layers of shielding, and backup systems to ensure safety in the event of damage. Future missions to asteroids or the outer planets will continually confront this challenge. It stands as one of the countless unseen threats of the cosmos, a testament to the fact that outside the safeguarding embrace of Earth's atmosphere, the surroundings are harsh and relentless. The hues of celestial bodies. Every planet within the solar system showcases a unique visage, shaped by its specific composition and atmospheric conditions. Mercury presents a gray visage, its rocky surface scorched by the relentless sun. Venus is enveloped in dense, yellowish clouds composed of sulfuric acid. The planet, undeniably, presents a striking palette of blue and white, with oceans and clouds taking center stage. Mars presents a rusty red hue, its surface cloaked in iron oxide dust. The gas giants exhibit a vibrant array of colors. Jupiter showcases stripes of cream, orange, and brown, whirling tempests, crafting elaborate designs. Saturn presents a pale gold visage, its muted tones concealing a rich tapestry of intricacies beneath the surface. Uranus presents a tranquil blue-green hue, a result of methane in its atmosphere that absorbs red light. Neptune presents a profound blue hue, characterized by turbulent dark storms and delicate wisps of white clouds. These colors transcend mere aesthetics. They unveil the essence of chemistry. The vibrant reds of Mars and Jupiter arise from the presence of iron and sulfur compounds. The hues of Uranus and Neptune are derived from methane. Through the exploration of colors, researchers uncover insights into atmospheres, surfaces, and the dynamic processes that mold these celestial realms. Every planet stands as a distinct experiment in the art of planetary formation, with their colors serving as hints to the tales of their pasts. The stillness of the cosmos. In films, spaceships thunder and explosions resonate. In truth, the vastness of space is completely devoid of sound. Sound necessitates a medium for its journey, whether it be air, water, or solid material. In the emptiness of space, one finds an absence of everything. Occurrences unfold in silence. A meteoroid striking a spacecraft occurs in silence. The thruster firing remains unheard by those beyond its reach. The stillness envelops the surroundings, creating an atmosphere that is simultaneously unsettling and serene. Astronauts speak of it as a deep experience, a stillness that is unparalleled by anything found on Earth. Within the spacecraft, a symphony of sounds unfolds, fans whirring to circulate air, pumps diligently moving coolant, and the steady hum of electronics. Yet, beyond its confines, there exists an eerie silence. Communication occurs through radio, utilizing electromagnetic waves that function independently of air. In the absence of this vital connection, astronauts would find themselves in a state of isolation, unable to communicate with one another, even when positioned mere feet apart in the vastness of open space. The stillness highlights the void. The expanse of space is predominantly empty, with immense distances lying between celestial bodies. In that place, sound held no purpose. Yet within that silence, beauty emerges. It offers a space for reflection, unattainable in the midst of chaos regarding Earth. For those who encounter it, the silence of space becomes an unforgettable memory, a testament to the vast differences between the universe and the world they inhabit. The legacy of the Hubble telescope unfolds in a manner that enriches its significance over time. Few scientific instruments have captivated the public's imagination quite like Hubble. Their images adorn textbooks, posters, and computer screens across the globe. The pillars of creation stand as majestic columns of gas and dust, a place where the birth of stars unfolds in all its grandeur. The Hubble Deep Field unveils a multitude of galaxies within a tiny section of the sky, no bigger than a pinhead, held at arm's length. These images transcend mere scientific value. They embody art, a beauty crafted by the universe itself. The Hubble Space Telescope has made significant discoveries that have reshaped our understanding of the universe. It assessed the pace of the universe's expansion with remarkable accuracy, contributing to the understanding that the universe is almost 14 billion years old. It witnessed supernovae in far-off galaxies, uncovering that the expansion is quickening, propelled by enigmatic dark energy. It observed the atmospheres of exoplanets, examining their composition by studying the way they filter the light from their star. After more than 30 years in orbit, Hubble remains operational, having undergone several servicing missions by space shuttle astronauts to replace malfunctioning components and enhance its instruments. The James Webb Space Telescope, while surpassing its predecessor in certain aspects, does not diminish the ongoing operational value of Hubble, whose unique capabilities continue to shine. The concept of space elevators stands as a testament to human ingenuity and the persistent quest to comprehend the cosmos. Among the most daring ideas for accessing the cosmos is the space elevator. Envision, if you will, a cable extending from the very surface of Earth to the vastness of orbit, an astonishing length of tens of thousands of miles. Vehicles ascended the cable, drawn by electric motors. The energy expense would amount to only a small portion of what a rocket launch entails, and there would be no requirement for fuel. It may seem like a tale from the realm of science fiction, yet the underlying physics hold true. The difficulty resides in the materials. The cable needs to possess remarkable strength while remaining lightweight. While carbon nanotubes possess the essential properties, the challenge lies in the fact that producing them at the necessary scale exceeds current capabilities. The cable must endure the forces of wind, the threat of lightning, and the potential hazards posed by satellites or debris colliding with it. A celestial body in orbit, such as an asteroid, could serve as a stabilizing force. Should it come to fruition, a space elevator would transform the way humanity reaches the cosmos. Launching satellites, supplies, and even people would transform into a regular and cost-effective endeavor. It would facilitate the extensive building of spacecraft in orbit and provide assistance for colonies on the Moon and Mars. At present, it lingers as a dream, yet researchers persist in their exploration of the concept, gradually advancing toward its realization. The space elevator embodies a future in which departing from Earth becomes as effortless as riding an elevator. As humanity ventures further into the cosmos, the emergence of legal and governance challenges becomes increasingly significant. Who possesses the Moon? Is it possible for companies to extract resources from asteroids? What occurs when debris from a satellite belonging to one nation causes damage to that of another? The issues at hand are regulated by international treaties, with the Outer Space Treaty of 1967 taking precedence. This treaty asserts that space belongs to all of humanity, prohibiting any nation from asserting sovereignty over celestial bodies. However, the treaty lacks clarity regarding resource extraction and commercial activities. As private companies increase their activity, the necessity for new agreements emerges. The Artemis Accords, embraced by various nations, seek to tackle certain challenges, laying down foundational principles for lunar exploration. However, not every nation has ratified, and conflicts persist. Conflict in space presents a genuine issue. Satellites play an essential role in facilitating communication, guiding navigation, and ensuring national security. Harming or obliterating them might lead to grave repercussions. Ongoing diplomacy will be essential to prevent the weaponization of space and to ensure peaceful cooperation. As the journey unfolds, the establishment of just and efficient governance will hold equal significance to the advancement of technology. The cosmos is a shared domain, and the manner in which we govern it will influence the destiny of countless generations to come. Envisioning the first Martian colony, one can see the initial human settlement on Mars, a collection of habitats, cylindrical modules, partially embedded in the Martian soil for protection against radiation. Solar panels extend across the crimson landscape, while wind turbines capture the sparse atmosphere. The greenhouses emit a gentle glow, their interiors brimming with plants, thriving beneath the illumination of LED lights. Rovers are parked outside, their surfaces cloaked in dust from recent adventures. Within the confines, a small community of individuals resides and engages in their daily tasks. They are individuals of science, engineering, and technical expertise, chosen for their talents and their capacity to flourish in solitude. Their days are occupied with various tasks, keeping life support operational, carrying out experiments, and broadening the base. With a 20-minute delay in communication with Earth, they find themselves needing to tackle challenges on their own. Meals are shared, stories are exchanged, and sunsets are observed, where the sun seems only half the size it does from Earth. The sky was a dusty pink. A sense of longing for home lingers perpetually. They long for the azure expanse above, the gentle caress of the breeze, and the refreshing touch of rain. The uncomplicated joy of stepping outside, unencumbered by a spacesuit. Yet, there is also a sense of pride that emerges. They stand as trailblazers, establishing the foundation for a future in which Mars transcends mere visitation to become a place of habitation. The children born there will represent a groundbreaking new generation, those who will claim another world as their own home. The colony, though small and delicate, represents a new beginning, a culmination of reflections. And so, esteemed audience, the exploration of the past and the possibilities that lie ahead in the realm of space travel reaches its conclusion. From the earliest primitive rockets to the grand visions of interstellar voyages, a journey unfolds, revealing the essence of humanity's greatest adventure, The bravery of astronauts, who dared to risk everything in their quest for the unknown, has been witnessed. The brilliance of engineers who transformed visions into tangible achievements. The commitment of scientists who delve further into the cosmos in pursuit of answers to the most profound questions takes on a renewed significance. The vastness of space serves as a reminder of the potential that lies within us. It reveals the remarkable potential we possess when we unite our efforts. As one embraces a vision that transcends personal boundaries, a sense of humility emerges, illuminating the insignificance of the individual within the grand expanse of existence. It inspires, presenting endless possibilities, numerous realms to discover, and maybe, one day, companions among the stars. As one lies here now, they may let their mind drift outward. Imagine a scene where one finds themselves adrift in the vastness of space, gazing down at the gentle arc of Earth beneath, while the stars twinkle in the infinite expanse above. Picture a figure on the rust-red surface of Mars, with the pink sky sprawling above them. Imagine being aboard a ship that glides past the magnificent rings of Saturn, or floats through the vast darkness between stars, journeying toward far-off suns. The odyssey of space exploration represents the collective adventure of humanity, and it continues to unfold. Every individual possesses a sense of adventure, a yearning to explore what awaits beyond the distant horizon. As they push outward, they carry with them the hopes and dreams of all who came before, lighting the way for those who will follow. The universe, immense and timeless, brims with marvels that humanity is just starting to grasp. Yet it is equally ours to discover, ours to hold dear, ours to transform into a home. Shut your eyes for a moment, take a deep breath. As the gentle pull of sleep envelops you, it guides you into dreams filled with distant worlds and starry skies, revealing new layers of wonder and imagination. May you find peace in your rest, wanderer. The cosmos stands still, timeless and enduring, poised for the unfolding of the next chapter in our collective narrative. That same dream is alive in you right now, and it lives in your children too. The universe isn't just something far away waiting to be explored. It's inside every curious question you answer, every bedtime story you tell, every time you look up at the night sky together and wonder what's possible. Science shows us that wonder isn't just nice. It's powerful. It lowers stress hormones, strengthens emotional resilience, opens our hearts, and reminds us how deeply connected we truly are to each other, to our kids, and to something much bigger than ourselves. If tonight's journey through the cosmos made you feel a little more hopeful, or reminded you why we keep dreaming for the next generation, drop a quick comment below. This made me dream bigger tonight. Or, I shared this with my kids. They loved it. Your words might light up the night for another tired parent scrolling right now. Thank you for unwinding and dreaming with Sleep Science Top 1. If this helped you relax and feel more connected, please give it a like, subscribe for more peaceful nights, and let sleep gently carry you among the stars. Sweet dreams. Good night from Sleep Science Top 1.